notes are about how to graph a parabola based on a shift that you might see in the equation. First of all, let's try to graph f of x equals x squared, that blue function. We know that we can find some points on that graph. If you plug in 0, we get 0, 1, 1, 2, 4, 3, 9, etc. But if you plug in -1, we get 1, -2, 4, -3, 9, etc. You've probably seen a graph of f of x equals x squared before, but I just wanted to graph that first so we could have a parent function to work off of, so we can graph the next couple functions as well. So there's our blue function. Notice our vertex of that parabola. We have a lowest point. Our vertex is at 0, 0. Vertex is at 0, 0. Now, from what you remember from translations in the last unit, you might notice something about the next graph. It's going to be in the same family, so it's still this parabola shape, but notice it is shifted 2 units to the right and up 4, based on what we learned about translations from last time. So to graph that, we're going to take all those points in the blue graph and move them 2 to the right and up 4. There's our new vertex. 2 to the right and up 4 for all of these points. So those top 2 points we can't really see anymore, but it does have the same shape. Notice it's still opening up, and our vertex is now at 2, 4. That should make sense because our original vertex just shifted. Let's graph one more. Let's graph -2x squared. This actually hasn't been shifted anywhere. Our vertex is still at 0, 0. But that -2 made it open down. Let's see what else happened to it. If you plug in 1, we get -2. If you plug in 2, 2 squared is 4 times -2 is -8. That's all the way down here. And if you plug in -1, we have some symmetrical points. Notice what happened. Multiplying by 2 stretched it by a factor of 2, which made it appear skinnier. So multiplying by 2 made it skinnier, and that negative out front made it open down. But in this case, we didn't have any shift. So if our parabola, our function, looks like an x squared function just shifted, we really shouldn't have any trouble graphing it. Let's just do one more and see if we can jot down some interesting things about it. Can you guess where the vertex is going to be even before I graph this? If you said -5, -3, you are correct. It's shifted 5 left and 3 down. Is it opening up or down? Well, there's no negative out front, so it must be opening up. What are some other points on that graph? Well, you can start from the original and shift them again, or you can plug in points near the vertex. Plugging in 10 is not going to be helpful here because it's not very close to the vertex. I know that if we plug in -4, we would actually get -2. If you simplify, we get 1 squared minus 3. And if you plug in -6, we also get -2. If you plug in -3, that'll give you 1. And if you plug in -7, you'll also get 1. For graphing the parabola, I think 5 points, 1, 2, 3, 4, 5, is good enough. I can really start to see the shape. So I'm just going to connect those and draw the arrows there. You might have noticed something kind of neat about the shape of the graph. It is symmetric. It has some sort of symmetry. So let's write down some stuff that we know about the parabola. Maybe if you compared it to something that you're used to graphing, like a line, you might notice some differences right off the bat. There's not a constant slope. So we can't really talk about the slope of this graph as a single number, like you can about a line. It is curved. It's kind of bowl-shaped or U-shaped. In this case, there's an absolute min. On the graph that we did on the slide before that was opening down, it had its absolute max. So we can say that it will always have, it has an absolute max or min, depending on which way it's opening. And this max or min is at the vertex. Notice that this parabola is symmetric. So we can say that it has an axis of symmetry. The axis of symmetry is the line along which you can fold the parabola so that it'll match up on either side. You can probably imagine it. On this parabola, the axis of symmetry is that vertical dotted line. For all of the parabolas that we're going to graph, the axis of symmetry will be a vertical line. Let's see if we can get the equation of this axis of symmetry. Sometimes I'll abbreviate it AOS. It's a vertical line, and it's going through the x value of -5. In fact, any point along that dotted line will have an x coordinate of -5. Ooh, -5. So the equation for the axis of symmetry is x equals -5. The axis of symmetry will always pass through the vertex because that's the point around which it's symmetric. So remember, we plugged in like 4 x values to get those points on the screen graph. I could have just plugged in a couple and then reflected them over the axis of symmetry. That might have been a faster way to graph this. So you want to make sure you use the fact that it's symmetric to get more points. Let's do some algebra with these parabolas. Notice all of the parabolas we've been working with have been in the same form. We're going to talk about different forms that these functions can be in, but for now we're going to stick with this form where we can always see the vertex. Let's see if we can solve, let's see if we can find these answers. Find the y-intercept. What we want to do to get the y-intercept is set x equal to 0. So what that means is we're looking for f of 0. Let's plug in 0 minus 3, the quantity squared, minus 4. Well, -3 squared is 9. 9 minus 4 is 5. Our y-intercept was 0, 5. I didn't even have the graph to look at, but I plugged in. Is that the same as the vertex? No, the vertex here, which it didn't ask for, but we can jot it down. The vertex is at 3, -4. We can see that from the shift. Let's try to find the zeros. The zeros would be where y is equal to 0. In other words, we're going to set the function equal to 0. How would we solve this? Well, you might be tempted to multiply this out, x squared minus, 6x plus 9, whatever. That's not going to be very helpful here. Since we're in this form, we can actually just solve for x by almost backtracking. Think about undoing all the things that happen to x. We can add 4 to each side. We have x minus 3 squared equals 4. Then we can square root both sides, sort of undoing the squared. And we get x minus 3 equals 2 or -2. A number squared equals 4. That would mean that that original number could have been two things, +2 or -2. We now have 2 equations to solve because of that annoying square root business that we had to do. X minus 3 equals 2 or x minus 3 equals -2. One of the solutions gives us x equals 5. I'm sorry, one of the equations gives us x equals 5. The other equation gives us x equals 1 when we solve. So our two zeros were 5, 0, and 1, 0. When we set our function equal to 0, we got 2 x values. Is it always so easy? Let's find the y-intercept here. G of 0 equals 3 times 0 plus 1 squared minus 5. Well, that's just 3 minus 5. That's -2. No big deal. So our y-intercept was 0, -2. But does it get harder to find the zeros for this one? Notice there's a 3 out front. We didn't have a coefficient that wasn't 1 in the other one. So let's see if this makes it harder. 3 times the quantity x plus 1 squared minus 5 equals 0. We're solving for the zeros. To get x by itself, we'd want to add 5 and then divide by 3 to get the expression with the x in it isolated. Now, when we square root, remembering plus or minus, we have that x plus 1 is equal to positive or negative root 5/3. That is an ugly number, but that's okay. We can still solve this. We're almost done. We can just subtract 1 from each side of the equation. Remember, this is really 2 equations. X plus 1 equals root 5/3, and x plus 1 equals negative root 5/3. We'd subtract 1 from each side to solve for x. Root 5/3 minus 1, or x equals negative root 5/3 minus 1. I wanted to show you this example so you could see that sometimes the zeros are not nice, but that's okay. We can still solve for them. Will a parabola always have zeros? Will a parabola always cross the x-axis? I bet you can think of an example in your head where it does not cross the x-axis. So sometimes we might try to solve and we won't get a solution. Let's sort of summarize what we know if we have a parabola that's written in this form. By the way, this is called vertex form. I know it's in vertex form because I can see the shift, so I can actually see the vertex. In fact, we even know that the vertex is at h, k. This is a general equation right here. F of x equals a times the quantity x minus h squared plus k. Our vertex is at hk. You can think of this as shifted h units to the right and k units up if h and k are positive. I know that the parabola will open up if a is positive and opens down if a is negative. What else do we know? I know that there's an axis of symmetry through the vertex. I can actually figure out the equation for the axis of symmetry. I know it's always a vertical line that goes through the vertex. Well, the vertex had x coordinate h, so the axis of symmetry must be at x equals h. That's the equation for our axis of symmetry. But I love, love, love vertex form because it's usually easy to graph out of, and we saw a couple of examples. It's not so bad to solve for the zeros of that function. So these are just some quick summary of some things that we know about it. So I encourage you to try to graph some more parabolas. Good luck!